Okay, guys, so these are the notes on how to predict experimental probability. Okay, so that's what we're doing right up there. So first thing, we're going to read through this example problem. So this is the example problem that we're going to be answering. So it says, if the theoretical probability is 3/8, can you predict what the experimental probability should be if the experiment is done 30 times? Okay, so I broke it down into 5 easy steps. So we're going to take it step by step. Step 1, we're going to do in yellow highlight. Okay, so step 1 is we want to find the theoretical probability. So if we refer back to our example problem, we can see right here, if the theoretical probability is 3/8, they tell us what the theoretical probability is. So we can write that in as the theoretical probability. And remember, when we can use our symbol for probability as just a P, and then show that it's theoretical, we put a little t. Okay, so the theoretical probability equals 3/8 here. Okay, and I'm just going to keep it yellow, just to keep it separate. Okay, step 2, we're going to do in green. So we want to find the number of trials. So trials means the number of times that we're going to do the experiment. So if we read through, if the experiment is done 30 times, okay? So that's what's telling us our number of trials. So I'm going to write in our answer is trials equals 30. Okay, so trials is 30. Step 3, let's do in this orange. So step 3, multiply the theoretical probability by the number of trials. Oops, wrong color. Let's undo that. Here we go, number of trials. So all we're doing is we're going to take the theoretical probability we found here and multiplying it by the number of trials that we found right here. So we have 3/8 from the theoretical times the number of trials, which is 30. So just to show the difference, there's the 30. There's our 3/8 from the theoretical probability. We're keeping everything color coordinated here. But step 3 said we needed to multiply. So going back to my orange, to multiply, first thing, our 30 needs to turn into a fraction. So I'm going to stick it over 1. To multiply, we go across. Okay, so the numerator times the numerator, denominator times denominator. 3 times 30 equals 90. 8 times 1 equals 8. Okay, there's our answer there. Okay. Step 4, let's do in blue. Step 4, we want to estimate the numerator divided by the denominator. Okay, so those are 2 keywords, estimate and divide. So we're just estimating this division problem. A fraction is just like division problems. So we're just trying to figure out what 90 divided by 8 is. Okay, and we want to estimate, so I use my squiggly equal sign. So on the side here, I'm just going to figure out how many times that goes into 90. So 8 goes into 9 one time. Like that 8, 9 minus 8 is 1, bring down that 0. 8 goes into 10 one time. So we're estimation, we can stop there and get about 11. Okay, so that's our answer here is 11. That's our prediction, okay? So in step 5, let's do pink. Here we go. Step 5 is put the prediction. Our prediction was this in blue. In a fraction over the number of trials. So in a fraction over the number of trials. And trials we had in green, so number of trials. Okay, so that's what we're filling in. So we want to make a fraction using our prediction over the number of trials. So here I have my prediction over the number of trials. So there we go. So just to finish up, just to color coordinate, we got our prediction right here over the number of trials. You see how I keep saying that? Because that's all we're doing to predict the experimental probability. So that is our prediction. If we were to do the experiment 30 times, we predict that 11 of those times it should be whatever we were figuring out when we did this theoretical probability. Okay, and that's it. Bye, guys.